Let's get started. I finally have a working machine. I'm making it more difficult to do that these days, but I had a complete copy of my hard drive, which I normally would just clone onto the new machine. But the security software they install on machines for campus now, you can't do that. So I had to hand move all the files, which was not too bad, except all the applications with license agreements. Um, I did learn one interesting thing. Some applications use absolute paths to files, and Dropbox, what happens to Dropbox when it thinks that the file is there when it's really over there? It gives you an error and won't run. So how do you tell if the file is moved location? Their solution is, well, you deinstall Dropbox and deinstall all the files that it creates, and then reinstall Dropbox. Like there's a path in one of those files, you just change it, right? And why does the application quit when it can't find that file? So I didn't deinstall everything and reinstall it. I just found the right file to edit. But they're in multiple places too, right? So where is it? Right? So for next couple, after today, I have next couple of lectures. Um, I just want people to read, parts of the refactoring book. I did not request it as a textbook for the course because the course would cost 50, 60, or 70 bucks. I forget what. And we're only going to read a few chapters. And it's available online for free through the library. So like most students probably for free over 50 or 60 bucks, particularly since we're not, it's only going to be a couple of weeks, right? A week and a half. Now they've made a number of changes over the summer to all kinds of things. And so the way you access it is the system is different than it has been in the past. Um, in the past, you needed to create a library account, and went from the library account, you log into the library account, and then you find your right link, and then you were done. Now what happens is if you have to use your San Diego State email address. So if on the reading assignment page, you click on that link, it eventually brings you to the library, it's a search, and then you scroll down, and you want Safari Textbooks Online. And then when I click on that, you get another page, and now you just enter your San Diego State email address and click Let's Go, and then it gives you access to all the books on Safari Online. And for those of you who don't know, Safari Online is a system started by O'Reilly. So there's tens of thousands of technical books online. And I actually subscribe to it because then I could do it on my iPad and download the book on my iPad so I can be on an airplane and actually read the books. So you enter your email and it will then bring you there, and then you can search for that book or any other technical book. So most of the textbooks I end up using these days are already online there. So okay, and I checked, and when you become a student at San Diego State, they give you a SDS. You get a red ID and a San Diego State ID, and when you got your San Diego State ID, they should have given you a San Diego State email address, right?
Right. Is an email.
Yeah, but yeah, I mean, that means you got an email address that you can use here. Yeah. Prior to that, students had to apply for an email address. Most students didn't because they already had one. So I was worried, like, oh no, I wanted to do the system. Like, no, half this class won't have email addresses, but no, you all have them. So we're good to go, right? Um, I didn't quite finish last time. I wanted the slides, and there's at least one slide that I want to get to. Um, some heuristics that I talk about when I taught 535. One is, remember we talked last time that class, an object represents data and operations together, right? And so heuristic is, that the data and operation should go in one place, right? Kept together. And another one is the class should represent an abstraction, not multiple abstractions. And that's often when I grade assignments, I look at the name of the class, and if it's some wishy-washy name, I go, okay, that's probably a bad class. Because it represents an abstraction, as Phil pointed out last time, it represents some concept, then the name should represent that concept, right? We saw the ultimate example last time. We got a class that just sets and gets, right? This particular, if you have lots of sets and gets, that's a sign that the data is in that class and the operations are somewhere else, right? And then don't create God classes. What's a God class? Anyone know what a God class is? What's that? Say it again. No, it's a global object, but it knows almost everything, or it does all kinds of stuff, right? So often what happens is I create classes how any operations, right? They don't do anything, but then someone has to do all the work, right? And so there's several classes which do most of the work. They grab data here and they put it there and put it back there. So they do all the work. And it's a God class, it has to know everything, right? It has to know all the other classes and how they work and what to do because it's doing all the work. And the third one is if I got a class and I have a set of data, another set of functions, if some methods only work with this set of data, and then these set of functions only work with this set of data, it's like, all right, there's probably two abstractions there, right? So usually, most of your methods should interact with most of the data, right? If I can partition the data in two pieces and the functions fall together, I can probably take that class and break it into 2 or 3 pieces. So if I were to ask you on an exam, what's the secret to long life? What's the answer? Now, do any of you think you're going to live a long life because you just read that? Right? So like I said last time, my degree is in mathematics. My first job teaching was at UC Irvine, the computer science department. It's like all these people knew all this stuff, right? And like you feel sort of intimidated, right? Because I mean, I could outdo them all in math, right? But I wasn't in the math department. I was in the computer science department. And so you sort of, on the weekends, you're like reading ahead, right, to figure out. And for me, it was interesting, like how do you write programs? And so you read all these software engineering textbooks, and just reading them is like, okay, what does this mean in terms of when I sit down and actually write a program or design a program, right? How can I take that idea and apply it, right? If I can't apply it, then it doesn't help me at all, right? And so for me, just being able to repeat back the answer, it doesn't mean anything. And actually, back then, it was everyone knew that dynamic programming languages were terrible, right? This was in the software engineering world. This was like absolute law, right? Dynamic languages cannot work. You cannot build large systems with them because the compiler doesn't check things, right? So languages like Python were just, you couldn't use them for big systems. It would not work. Um, and no one questioned it. No one questioned it, right? And you read the books, that makes sense, right? Because the compiler helps you check all these things out. Um, and then one time I came across this book on small talk, and it's like, what are they talking about? What are they talking about? I couldn't understand what they're talking about. So I got a small talk system and started programming it. And at one point, I was building a system and I needed some stuff. And so I bought the source code for this huge application. It was millions of lines. I mean, it was multiple millions of lines of code. It was actually, it did spreadsheet, it did word processing, it did databases. Um, and in your database, you could have a spreadsheet. And in your spreadsheet, you could have a database. And in your document, you could have a database. So you could nest them all you wanted. Um, and so I was basically able to extract all these millions of lines of code of the system, right? Pieces I need and use them, and it worked, right? So I was using several hundred lines of code from the system in my program, and it worked fine. And the compiler never checked types. And so you step back and say, well, everyone says this should not work, right? I shouldn't be able to do this. This program shouldn't be able to run. So then I was like, I realized, okay, the story here is far more complicated than people were saying. And so just memorizing stuff is not actually learning. It's not, in this field until you can actually apply it, right? And computing is very trendy, right? It's very trendy. Um, so at one point, object programming was going to solve all the world problems. Now it's AI is going to solve all the world problems. We overhype things, and so we need to step back and just ask ourselves, okay, how do we do this, and then pay attention to what effect it has, what its limitations are. Um, so I asked you to read two papers, right? Um, one is a big ball of mud, and the other one was. So what don't they tell us? Right? And he said it's hard to write good code. Yeah, very common, right? and programmers will complain about it, right? And we often write code with messy, thinking we'll go back and clean it up. And does that happen? Sometimes, but an example of it is, right, the big ball of mud paper came out of University of Illinois Champaign-Urbana, which is like one of the top 5 computer science departments in the country, and it's probably in the top 10 in the world, right? So these guys are, I mean, it's tough getting in there, right? These guys, um, and so the group that wrote that paper, the people that wrote that paper, were in the software engineering group, and they run a conference every year on design patterns. And so when the World Wide Web came out, they wrote this program to help registration, right? So you can do it online, and they admit the code is a mess. It's just terrible. It hardly works. It's sort of, you patch up a little bit every year just to keep it running. And these are the people, right? These are the graduate students in one of the top computer science departments in the world. And they wrote it. And they admit, and they study software development. And they admit that that code is a mess, right? And I'm pretty sure almost every company that has software has similar systems, right? It's a complete mess, and we just keep it running. Um, and I've got several programs that are a complete mess, and it's like, still works. So what's the cause of bad software? Say that again? Yeah, so one is the quality of programmers, right? And one of the authors of the Design Patterns book, he likes to say, on average, the average company has average programmers, right? Um, and time's always a factor. And what does he say is a fix? Has anyone here actually maintained code other people have written? And how were the comments?
They're kind of self-documented. Variable names like S1 and
Too,
S2.
right.
So
But when there are comments, how good are they?
a lot of times it's obvious.
Right. And if they don't repeat what's obvious in the code, often it's wrong, right? Because no one goes back and actually,
Yeah, especially at the top of the file,
right,
everything that talks about what the file's going to do and what the class does. That's always
right. So that goes back to the time factor, right, and the quality of the programmers. Um, so the problem with comments is they're separate from the code, right? And so even within the same file, um, as the code gets mutated, the comments often don't follow suit.
architecture document, design document.
Yeah, I mean, they're somewhere else, right? I mean, where are they? Who knows, right? Which means even if you want to update them, it's like, okay, where is it? Go find it. And like, oh, well, maybe not this week. Because I mean, you have to find it, right? Um, And usually the architect has that, and us new programmers may not have it, right? Um, so yeah, the current thought on comments is that one is hard to write comments, and often comments, like you say, are just repeating the code, right? And I forgot to bring, but my favorite example is x equals x plus 1, right? And then the comment is add 1 to x. And yeah, I know that. I could see that. What I don't know is why am I adding 1 to x, right? Or what is x, right? Yeah, I mean, right? So often the comments are just repeating what's obvious in the code, which doesn't help, right? And I would argue it actually doesn't, not only does not help, but it slows you down because then you're going to read the comments, figure out what, hopefully it adds something, right? But it doesn't add anything. And so you're like, oh, the comment, oh, look. Um,
What was the simple fix?
is there a simple fix? Yeah. What's the big ball of mud? Has anyone worked on a big ball of mud? Medium-sized ball. But what is it? But it's hard to maintain, right? And it's very hard to add features, right? Um, so I had a student who worked at a local company once, and the company name will remain. I won't tell you the company name for obvious reasons. Um, they had one of their main products. This one programmer wrote a lot of it, and the main function, the main was 10,000 lines long, and no one could, except that programmer, could touch it without breaking something, right? Whenever to add a feature, anyone who tried to add a feature because of that big long main, something broke. Only that one programmer could do anything, and the only solution was you maintain that and rewrite it. And when the rewrite has enough features, then we can swap them. But there was no way they could actually modify that code because it was such a big mess, right? It was 10,000 lines, one function, one method, right? And it was so intertwined that you make a change here, it affected someplace somewhere else, and it's common, right? It's not. It's common. There has to be a reason, right? Um, what's that? Yeah. So yeah, it's basically one is a short time and you don't have time to do a good job, and yeah, lack of programming. I mean, so it's again, you have the average company has average programmers. Complexity. What else?
The specifications of what the customer needs throughout the project.
Right. And so things are changing and modifying, and Yeah, that's sort of similar to the specification changes, right? Right, it's only going to do this, but then we decided to do this, and so we just, anything else? Yeah, yeah, the problem with prototypes is your managers don't believe in prototypes, right? It's almost done, it's sort of working, right? So it's only taking a couple of weeks, right? Like, no, I told you it was a prototype when we cut a lot of the corners. And
Um, they introduce too much. Programmers will introduce too much complexity that isn't needed because it isn't needed or necessary, or maybe for job security. It makes everything harder.
yeah, us programmers like complicated things, right? I mean, that's a very hard thing to learn is don't make things so complicated. Don't worry about all it, right? Because you always worry about the edge cases and what if this happens? What if this happens? What about these features? Right? It's just,
Yeah, I guess.
yeah. So again, the paper lists a number of different patterns, right, that um, are related to creating big ball muds, right? Look, if you're a startup company, um, at some point you have to ship, right? And until you ship, there's no income. So it doesn't matter. I mean, if your software is terrible, right? Um, it doesn't matter. I mean, if it works, you can ship it, right? So at one point, um, I spent a year at UIUC, and this gaming company came and talked about their game engine, and they talked about how great it was, a great architecture. We did all these great things. It was so wonderful. And one of the students in the back said, "Yeah, but your game sucks." Right? I mean, like that was a problem, right? I mean, if it's a gaming company, what really matters is how good your games are, right? How interesting they are. And they spent all this time up front creating this great gaming engine, but then they weren't able to produce the games. So it's like, okay, just you have to get it out there. Otherwise, you don't have no revenue. There's no revenue. Eventually, you can't pay your programmers and go away. Well, when this paper was written, the authors were not quite convinced about agile development processes. It was relatively new at the time, and they weren't quite sure it actually would solve the problems. Um, so they're talking about top-down design, um, building a good architecture. The problem with that is, as you say, requirements change, right? And so if you spend 3 to 6 months building this great architecture, um, and the customer calls you up and says, "Well, but things have changed," right? And all the world runs on software, and it changes quite rapidly, right? In the mobile phone business, Android and iOS come out new versions every year, right? And there's new phones coming all the time, and so those companies are continually having to, get those new chips and get their software running on those chips and doing the new operating system. Um, and it's not like you can say, well, we're going to take a break this year and just fix things. It's like, no, Samsung has how many phones coming out every year? I mean, and different chips in different countries and different languages, like, and hire good architects, but how many good architects are there? Yeah, we talked about all this, right? I mean, S1, S2, right? Bad comments, um, 10,000 lines of main, right? Or right. So we tend to do this, right? We tend to build the most complicated system we can. And then what happens? It gets so complicated, it's hard to modify or maintain or modify. So it stays at that level of complexity, and we just beat our heads against it and slowly keep it running. So what are the three ways to deal with big balls of mud?
Sweep it up the rug and reconstruction.
Yeah, so there is just rebuild it, right? Rewrite it. Um, and sweep it on the rug, basically, you write a wrapper around it so you don't see it anymore. What's the third one? What's that? We just say don't build big balls of mud, right? Yeah, as I said, reconstruction one is and just hide it in a wrapper.
One thing I really is to have we have periods of expansion, we're
Right,
making the program do more, and we have periods of, there was two words that they used. One of them was refactoring, and
right.
there was something like the opposite of expansion, reducing
Reduction,
code,
right.
reorganizing code.
Yeah, and that's um, so extreme programming came out almost 20 years ago, um, and it had various practices. One is pair programming, so that multiple people involved at the same time. Um, coding standards, simple design, right? And at the time, the creator Kent Beck, said, well, if the practice is good, let's turn the dial all the way up to 10. And so instead of code reviews, they're programming and then having a code review. Why not do it in pairs? So you're basically always doing code reviews, right? You get two people. Um, at the time, extreme programming came out and was very popular. I knew a graduate student who decided to leave graduate school and go to work, and he went to San Francisco, right, to interview all the big companies because that's where all the action was, right? And he said every place he interviewed said they were doing extreme programming, and he said, yeah, and at most they were doing two of those, at most. Usually they weren't doing any of them. Again, that's part of the hype of the industry, right? It was popular, so we're going to do it, which so it means we're not going to have to do top-down design. Um, we're just going to set programmers out to start coding away. And pair programming, that's expensive because now you've got two people on this, right? So,
That's really expensive. It's expensive up front to do it that way.
right, yeah, yeah. And it's hard to convince managers to support that. Yeah.
It's just you
Right, yeah, right.
guys.
The throwaway code pattern, right? So I once had a student, um, I was amazed he didn't lose his job because he went to a local company and basically said he finished his degree here, but he hadn't. Um, so he was still going to school and they thought he was not. Um, but they were working on a simulator to run Cray code on the supercomputers. Uh, and it was like, and they gave him the job of writing the simulator. It was like, that's pretty gutsy to handle a new hire to write this complicated thing. So he worked on it, and at one point, um, he realized that he had made some decisions early on which were not good. But like all software, right, it's a learning experience, right? I mean, usually you start knowing a little bit, and then as you go forward, you learn more and more and more. And by the time you're done with it, done writing the software, you really know now enough to actually start, right? And so he got halfway through, and he told his manager, "Look, um, I can make this work, right? I can take the software and I can complete the job, but I made these bad decisions early on because I didn't know any better. Um, Give me some extra time and I'll start over again and we'll end up with better software." And his manager agreed, but that's sort of rare, right? But the problem with throwaway code is it's hard for people to throw it away. And so one way I know people, particularly when you're trying to figure out the interface, one way to get around that fact is you don't use you use paper to prototype the interface, um, because then no manager says you're almost done, right? Because what you're doing is you're putting it on a board, right? So this is what it look like, and then you can say now you can click here. Now someone changes the board, shows what happens, so that we can see the workflow of the software without having it on a screen, making people think that it's actually doing something. What? Can't ship it, yeah. And the main problem is that it's hard to throw it away. And I bet all of you had this experience, right? You're writing software on a project, even for school, and you took a bad turn, right? You decided I'm going to go this way, and it's not working, it's not working. And it's like you're so invested in what that little bit you did, right? You beat your head a goal to make this instead of throwing it away and starting over and saying, no, that's it, right? We've all done this, right? You've all made a bad decision and you weren't willing to drop it because you were just so emotionally invested in that decision and that work, right? You're like, oh no, I'm going to waste 2 days worth of work, and then you're going to invest an extra 4 days extra to get it, force it through than if you were just thrown it away and start over again, right? We all do this, right? So the piecemeal growth, right, is this is how do we deal with changing requirements? You you, you satisfy part of the requirement, then you see, right? And the requirements change, we just add more stuff, right? And this is what the agile people talk about is, well, you don't start and build a huge system. You start building a small system, and you keep on adding the functionality that's required. And because that's the only way. If you try to design the whole thing, by the time you're done designing, the requirements have changed, and so you start over again. So just take the most important thing and make it work, and then take the most important and make it work. Um, but that's the key, right? Is you have to step back and say, "Oh, wait, we have to reorganize the code to go forward."
In practice, you almost have to do that behind backs. Because
Because
the programmers know something needs to be refactored and needs to be worked on, redesigned, but managers will never say, "Yeah, go ahead. Let's not add any. Let's just go and start refactoring."
right,
You have to
yeah,
be cognitive about it.
yeah. Um, I once talked to a manager, and he said, "Yeah, he said most of my colleagues think programmers will never release code. You have to pry it out of their hands, right?" Um, and so that's why when they give you deadlines you don't think you can meet, they say, "Well, that's just the programmers. They'll never. I mean, they'll hang on to the code forever." So what's wrong with giving them a deadline that's a little bit too soon? Because they're always going to want more time, right? So just pick a date, do it. Big ball of mud, right? Yeah. And what's the biggest problem with this piecemeal growth? No refactoring, right? And then it becomes this big ball of mud. Just keep going, right?
But I've always found that the longer you've gone with some big design change and haven't gone back and tested it works, the more risky, exponentially more risky that you'll ever get.
Yeah. So there's this great story, Fred Brooks. He was a guy that he wrote this famous book, the Silver Bullet, I forget the actual title. Um, he actually was the one that designed the IBM 360 and was head of the project. And this is a huge system, right? Um, and so when he finished that, he went became an instructor, professor at university, and he taught students, well, you should make small steps, right? Just make small steps, right? Right. Um, and so he tells a story where students are in the lab working, and he talks to them, and he talks about small steps, right? And then he went away and had meetings. He came back hours later. Um, and I go, how's it going? Well, we don't know yet. We're still typing in code. It's like, wait, didn't we talk about doing small steps, right? And um, they didn't quite understand a small step. I mean, you don't type for hours and then try and compile, right? It's impossible. And when I first started teaching, I taught basically these are first year students, so they were just starting, right? And this is one student that, well, gave this assignment is basically the third quarter of the first year, and the student came in, and this his code was so complicated and so messed up. It was like he wanted me to help him fix it, and it's like I couldn't understand it, and it's like, oh, and he went away frustrated because he wanted me to help him. It's like, no, this is so bad that what you really want to do is just throw it away and start over again because it's a mess, right? You'll never get it to work. So I'm sure he thought I was an idiot. Like, you're the instructor, right? I mean, it's just, it's a freshman level assignment, so you should be able to fix it. But no, right? So yeah, this piecemeal growth, you just add. If you don't refactor, it becomes a mess, right? And just keeping it working also can lead to a big ball of mud, right? So then when you want to do that, I mean,
You do want to do it. You just have to go back to design.
right,
You have to have that periods of refactor.
right, yeah. This one's a little bit harder to understand unless you've written a lot of software, right? Because some software changes at a higher rate. Um, and that affects things around it, right? That use it. Um, so what we're saying is, yeah, if there's certain things which hardly ever change, that becomes your core. Keep that separate from things that change a lot because those things that change a lot, really, those changes can propagate out. And if you take things that change a lot and you scatter them everywhere, then those changes are going to just propagate the whole system. Um, and so, yeah, build these layers so that, okay, this layer is stable, this layer just changes a little bit, this layer changes a lot. And so then you can hopefully isolate those changes, right, into that layer, not have it propagate through the whole system. Particularly if you're good enough to, have APIs between the layers, right, and keep those APIs from morphing too.
Yeah, I thought a good example of that was like user interfaces, where
Yeah,
a lot of people used to, especially in the old models, a lot of functionality in that.
like,
And now, the standard now separate your your UI is just your UI, and it
right,
goes into an API because user interface changes all the time.
yeah,
In fact, if it's a good user interface, it should be highly customizable. Framework.
yeah. So the whole idea between the model view controller, right, patterns that the view is just responsible for what the user sees. I mean, just put a wrap around it and you know it, right? Yeah. There's still a lot of COBOL code out there. You can always put in a separate process, right? Anyone remember Netscape? Yeah, in fact, it was um, It was like the first GUI browser. Um, and it came out, and they were on this huge struggle with Microsoft, right? Because Microsoft decided they wanted to dominate it. Um, and for a long time, they were neck and neck. But what happened is that the Netscape people, they basically programmed themselves into a corner, right? The code became too complicated um, and too hard to, it was a big ball of mud, right? And it was hard for them then to add new features. And so at one point they decided, okay, we're just going to step back and do this. And it was game over. Why? Well, because that meant while they were redoing their base code, right? Microsoft adding more features, more features, more features, and all of a sudden, people are going, nothing's happened in Netscape, and all the stuff we want is over here, and so their market share just collapsed, and it hasn't recovered yet, right? What's that? Oh yeah, it morphed into um, Mozilla, and then Firefox, yeah. But it was a long, long. I mean, the company itself is gone, right? So it's a
Back then, whoever controlled the browsers could pull vector HTML and the standard.
yeah, yeah,
That was like fast moving.
yeah. But that's so the problem with the reconstruction is what do you do in the meantime, right? Now you've got the old product, the new product, and usually when you have it, when you got a piece of software that's large enough to sell, make money from, it's complicated. And there were probably lots of bugs and other things you did wrong, and you corrected them. And those people probably aren't working for your company anymore. And so when we start over again, people are going to make the same mistakes over again, right? And introduce some of the same bugs. And it's hard to come up to parity with what you built over the years. And I think the best example of that um, is the software we use to control airline traffic. There have been several attempts to rewrite that software. IBM at one point was given a $1 billion contract, $1 billion to produce, modern software to control airlines. It failed. They couldn't do it. And that wasn't the only attempt. So in the meantime, when you're flying airplanes in this country, you're relying on old mainframes, running software to track where the planes are. And the machines are old enough that they have to, they're hand manufacturing parts. The problem is once you get so far along, and it's one thing to start out like my student did, right, before it got finished. Okay, we need to throw it away and start again. But once you're shipped, how do you do that? Because then you have the old product and new product. And if the product has several versions, right, you spent the last 5 years on this product, and now you're going to start over again. I mean, you may think it's not going to take you 5 years, but it could take you several years, and now all of a sudden your product is static, right? Or you have two teams, one pushing forward the old product, another one trying to do a new product and catch up to the old team. Yeah, I mean, it's the cost and the time. So in literature, there are very few people come out and say, in general, software is pretty low quality, right? Yeah, low quality, right? Very common. So this big ball mud paper became quite famous for stating the obvious. Now, if you don't know, Kent Beck is he and Ward Cunningham um, have been very influential in the software development world. They started when they were just starting out. They worked for a company called Tektronix that built um, oscilloscopes and other type of instruments, which was a weird place for software people. But basically, all the instruments they built, I mean, they had the hardware, but you needed the software to make it work. Um, and their job was when software teams got into trouble, they were the ones they brought in to help them out. And so I spent a number of years just going from project disaster, fixing them, right? So they got a lot of experience of what things could go wrong, which gave them lots of time to think about how could we do better. Um, and so Kent Beck is the one that created extreme programming. Um, and so he has some guidelines for good style. Um, once and only once. The problem with repeating your code is that, well, in preparing every semester, right, I have to sort of start a class out, and there's certain things you specify, okay, when's the final, right? When are assignments due? Oh, that should go in your syllabus. Oh, it should go on your website. Oh, it should go on my calendar to show you, due date, due dates, assignment, exam, right? So all of a sudden, I get the same information in multiple places, and invariably, I just like, oh wait, no, that's not going to work. I need to change that date, right? And then you forget to change one spot, right? And then some well, is it on this date or that date? You said this date, right? And it's like as soon as you, as soon as that information is in two or more places, you're just asking for trouble, right? If it's in four places, you're just dead. I mean, at some point you're gonna get it wrong, right? Um, and you've all done this at some level, right? You're just like, you're gonna copy this code and put it over here, right? As soon as you do that, you got things in two places.
Well, then a lot of times that takes time. You have to invest time if you're going to write new code to go back to a lot of other code and say, have I done this before?
Right.
Or has this been done before? It's always better.
Yeah, yeah. But the problem is, what's already been done may not be quite in the right shape or the right place to reuse it somewhere else, right? Yeah, but it may be that it turns out that two completely unrelated classes do the same functionality, right? Same small piece, and they're not related. So how do it doesn't make sense to make this apparent for that apparent. And so then you have to go back and think, where should that piece go? And then how do I get it from in here and here? But yeah, if you're not doing that, I mean, you got the problem. You're gonna you're going to repeat yourself, and then at some point you're going to change one and not the other. Or,
It is nice though when you have everything organized that way
yeah,
and you have to make a big change to a lot of
change. Yeah, yeah, it works, right? Lots of little pieces. I mean, if you got a 10,000 line main, you know you're repeating yourself a lot because there's, I mean, there's logic in there that's been several places. There's no way to get around it. Alan Knight's another interesting character. He wrote this paper about all you need to know is you can learn from Dilbert. Um, so if you're not familiar with Dilbert, it's this famous comic about, you know, software team, right? Um, and that's Dilbert. That's Wally, the lazy, no good programmer. Um, right. So it's basically a comic about office interaction in general, and in particular in the software world or engineering world. Um, so Wally's always he never does any work, right? He makes sure he makes sure everyone else does the work. He doesn't do the work. Um, um, and so the one lesson is, yeah, when you're writing software, you don't want your class to do everything. Right? It shouldn't be a god class. It shouldn't do all this extra work. Um, so instead of you running around doing all this, it's like, okay, no, I have people working on me, so you could do this, you do this, you do this, and when you're done, give me the result, and I'll put it together and use it, right? And so yeah, when you write software, it's the same thing, right? You want a class to have represent an abstraction, and different abstractions do different things, right? And so your class shouldn't do everything. Like, well, you should be able to say, okay, this is so low level, so you go do it, and this is you go to do it, and then I'll combine it, and then I'll get my result. And so a lot of when you're building classes is who should be doing what, right? So avoid responsibility. Rather than this class having to go and link, you just tell Root, okay, you add it, right? And the Root can say, okay, it either goes here or there, and then you'll tell that one to do it, go here, and then this one will tell you go there, and right, rather than you going and put it here, it's like, okay, I can say, okay, it goes in the Root, and the Root can say, well, okay, it either goes left or right, right, or in the middle, and then you do it. And now I decided it goes in the middle. The middle thing should figure out where it goes from there, right? Sort of classic definition of classes and objects, right? A class is a template. It defines the data and operations that the class can do, and the object is a runtime instantiation of that idea. It has a runtime storage for the data. Um, right, and so there it is. A couple, and there's lots of different ways, different languages define classes slightly differently with different syntax, but it's a class, and there's a slightly different definition, right? To slightly more pull back from low-level mechanics of things, is a first-class dynamically dispatched behavior. What does that mean, right? Um, Behavior is just, it does something, right? Operations, functions, whatever you want to call them, right? Um, Dynamic dispatch means that different objects with the same operations, same names, but they do different things.
When you say first class, and I've heard that referred to as
Yeah,
like some language for first class
right.
functions as first class objects. Can you elaborate on? Oh, there you go.
Right. So the object has the same capabilities as other values, right? So when they call a function first class, they're saying it has it's at the same level as functions defined in the language, right? They do the same sort of things.
Being assigned to a variable, pass it as a method.
Yeah,
Hopefully, not too obscure syntax.
but it just um, the types you create are at the same level as the types in the language. They're not second-class citizens. They can't do all the same. There aren't restrictions that you can't do that they can do, right? Right. Now, Alan Kay is the one that created object-oriented programming, or he is the one that's given credit for doing so. Um, and he says he regrets using the word object. So for him, the big idea is messaging. Right? How do we get something done? I send a message to you and say, do this, and then you may do some of the work, and you send a message to someone else, right, to get do part of it done. And so there's this whole lot of messages that go out to get work done and flows back, right? So it's the messaging and sending those things out that he considers a big idea. And then, right, that this hiding things right locally. And the light binding, right? Um, you see that a little bit in Java, where I can swap classes in or out, right? Objects for different. I can take a sub object from the subclass with a subclass and interchange them, right? Um, Now Python is more dynamic because you don't even have to be subclasses related by classes. As long as they got the same methods, I can just swap it in a variable and replace it with another one, right? So his big idea is the messaging, not the object part. That's how the pieces communicate, right? So people talk about there's abstraction, right? Abstraction is just what are the important parts of this, right? The table, what makes it a table? What's essential for a table? I have a stack. What are the essential properties of a stack? Well, there's first in, first out. That's it, right? So that's what the idea is. What are the important things, right? Putting these things into containers and capitalization. You can have abstractions in C, right? I can build a stack in C. Um, but there's no encapsulation, right, in C. There's just a struct here and a function there and a function there. Now, encapsulation does not mean things are hidden, right? In Python, we've got classes, but everything is public, right? There are no private anythings in Python. People make things private by underscore underscore, right? But that's a naming convention. I can still, once I know it's there, I can still call it, foo dot underscore underscore function name or get its data. And information hiding is this making sure the rest of the world can't see what's going on. Right? These are three related but separate ideas. Right? We can't have abstraction without the other two. Just because you got encapsulation doesn't mean you've got information hiding. Right? And so this class, like we said earlier, this is data plus operations, right? And the goal is to hide the inner workings of that class in the outside world so we don't have to worry about it. Right? Right? Hide all your data. Class should represent a single abstraction and keep related data and behavior together. What's the utility method? It only acts on its parameters, right? If it only acts on its parameters, I can put it anywhere and just call it. So here's an example, and I'm going to rush through it, and I'll start again here next time. This is a big idea. So I've got some crossword puzzle and class, and it does something. I need to count vowels, right? Because you know how long it is. And then, okay, what I do is like I just create a function to count vowels, right? And I do all the work here. Um, the problem is that's not reusable, right? And what does vowel counting have to do with the crossword puzzle? What's the abstraction there, right? And this, if I was in C++, I could just make it a separate function, right? In Java, I can't, so I just put it into class. Um, let's look at a different version, right? So I create a vowel count method in the string. Why? Because that's where the data is, right? I mean, the characters are in the string class. And so now I can put it there, and I can use it anywhere I want, right? And then the character class, I mean, what's a vowel, right? Different languages have different vowels, right? And now it's just, there it is, right? So now I've got smaller pieces that I can test independently and can be reused, right? The probability of errors goes down, right? It's simpler to write this code. I can reuse it. Now the problem is, well, it's better. Like I just said, why it's better, right? It's easier to test, small, reusable. Um, but in Java, we can't do that, right? You can't do that, and you can't do it in Python either. So what do we do? Well, in Java, we do this, right? Because you can't do the other thing.
You end up having to make a static class of everything you wish you could extend string to. You end up having a static class sometimes you just have a go-to static class that has all the things that you can.
Yeah, but it's clunky, right? It's clunky. And it doesn't really work, right?
Unless it means they're better option.
Well, my point is, if we want to do, if the goal in object-oriented programming is to keep data and operations together, right? And I'm trying to teach students how to do that. It's helpful if they can actually do it in simple examples, right? If you can only do it in complicated examples, how do you ever get there, right? Because all the time you're doing things like this, right? And then you say, well, I'm doing object-oriented programming because I'm using Java, but I'm doing this, right? You just over and over again, or you put it in a static class. In a static class, just becomes there's functions, right? And so again, there it's like, oh, we're not keeping operations and data together, right?
But your point is that final classes are in this instance.
Well, that's a different story. The problem is, how do we ever learn how to keep data and operations together if we're always doing this? Because the language doesn't let us do what we should be doing, right? And that's why when I taught 535, I would never use Java. It's like I couldn't give students simple examples to do this. You have to give them complicated examples, and then complicated examples. You want to start out learning simple things, right? Apply the principle in simple cases, and then go on to more complicated cases.
I mean, it's a simple. Let's not use Java string. Your own string.
But you can't do it in Java, right?
You can make a new string. Call it string one.
But the problem is,
My string.
you can never. Strings are so pervasive in
Yeah,
Java.
and some languages have special mechanics.
Yeah, but so yeah, so there's
They're immutable a lot of times.
so in Swift you can add things to existing classes. So in Swift we can do that. In Smalltalk we can do that. In Kotlin we can do that. So next time we'll start here again because this is